Welcome everybody to today's webinar by the IEA SHC Solar Academy. Please hold the line and we will begin shortly. Welcome everybody to the webinar. Please hold the line and we will begin shortly. All right. Welcome everybody to today's webinar by the IEA SHC Solar Academy and hosted by ISIS. Before we get started, I'm going to give you a short introduction into ISIS and the work we do before we enter the presentation part of the webinar. So ISIS, who are we? ISIS, the International Solar Energy Society, is a UN-accredited membership NGO. We've been founded in the 50s, and today we have individual and corporate members from countries all around the world. And our purpose is 100% renewable energy for all, used efficiently and wisely. To achieve our mission, we have biannual congresses all around the world. One is called Eurosun, and the other one is called the ISIS Solar World Congress. So you see we've got one coming up next year, and then the next Eurosun is going to take place in 2026. We also have two major scientific key publications, the Solar Energy Journal, which many of you will be familiar with, and our newly established Solar Energy Advances Journal, which is a fully open access journal. Additionally, we provide services such as the webinars, one of them we are attending today, and we have educational initiatives both online and offline. Additionally, we also provide infographics on solar themes, as well as our newly established Solar Energy Museum, which is a fully virtual museum, which you can visit and walk through 60 plus years of solar history. Now, just one quick information before we get started on the webinar. There will be a Q&A session for your questions at the very end of all presentations. As the webinar progresses, you can type in your questions in the Q&A box and we will collect them, and then our moderator will distribute the questions to our panelists. When you submit a question, please keep your question short and precise and indicate which of the panelists the question is for. Now, it's my great pleasure to introduce you to the moderator of today, Bärbel Epp. Bärbel is the founder and managing director of the consultancy Solvico. She produces the Solar Thermal World newsletter, and she's also responsible for the Solar Heat Ship report every year. And with that, I'm happy to hand over to Bärbel. Bärbel, please take the floor.
Thank you, Arabella. Great news. I welcome everybody to this webinar today, another IEA Solar Heating and Cooling Solar Academy webinar. I will give you a short introduction into what is the IEA Solar Heating and Cooling Program. It's a long-term standing R&D collaboration with 20 member countries that you see here on this map in red colored. The orange marked countries are member of the IEA SHC via supporting organizations. We have more than 200 experts around the world, and they work together in different research platforms. And we have listed you a number of topics we are currently working on, which is the solar energy buildings. We have compact thermal energy storage. We have solar district heating, low carbon, high comfort lighting, and solar hot water for 2030 is another topic. This is sort of the today's topic. Well, we should get to the next slide this way. Yeah, what is the Solar Academy? What does it mean? It's a platform of the Solar Heating and Cooling Program that distributes the key finding and results from the distant task work. We must say that we not only publish scientific results, but you find on the website also a lot of training materials, case studies, fact sheets, sometimes a database, also a lot of tools. The IEA SHC Solar Academy organizes and hosts the webinars hosted by ISIS. The next one will be in November on efficient district heating. You are all welcome to join that next webinar as well. We have a video channel on YouTube with expert interviews from different conferences, and we offer on-site trainings on the request of member countries. The last ones have been in the Caribbean, China, in West Africa, South Africa, and United Kingdom. You can obviously result the website for more information. There is a special section on the website under publications where you find all the latest reports. We have social media channels. Please join us there as well. And if you have additional questions, here's the website, the contact to the secretariat where you can get all further requirements. Two flagship publications that the IEA SHC program is regularly publishing. The Solar Heat Worldwide study is usually published in June. It's the most comprehensive report on national, global, and application-oriented data on solar heating and cooling. And some of the speakers will quote charts and results from this report also in their presentations today. And we have the Solar Update, which is published twice a year and features some special articles about task work or about interviews with task managers and gives you a brief insight into the latest results from the program. Yeah, this brings me to our webinar today. It's organized by the task on Solar Water Heating 2030, and it's titled Manufacturing and Design for Reliability and Durability of Solar Thermosyphon Hot Water Systems. And the first speaker will be Robert Taylor from Australia. He is professor at the Faculty of Engineering at the University of New South Wales, where he served as an academic since 2011. His main research interest is in the development of next-generation solar and thermal energy systems. His main goal is to provide a more efficient and economic coupling between solar energy and useful thermal and/or electric energy, and he has published more than 300 academic publications. He will now give us an insight or an overview on what is worked on within the Solar Hot Water for 2030 task. Robert, I'm looking forward to your presentation.
All right, thank you for the introduction, Bärbel. And yeah, I don't want to repeat the slide you just showed there, but yeah, just wanted to give a little bit of a short introduction before we head over to some of the experts from our task and a subtask leader. And this is, as was mentioned, this is coming out of task 69 from the Solar Heating and Cooling Program, where I'm one of the task managers. The other task managers probably joining the call here is Professor Hertau. And basically, the point of today's Solar Academy is to discuss some of these issues that we have with thermosyphon systems, that even though thermosyphons have been around for a long time, they still suffer from some issues in some markets. And yeah, hopefully there's some ways that we can think about alleviating these issues through either design, operation, or just general best practices and getting a good fit for the technology to where it's actually installed. And before we get too much into the details about thermosyphons, I'll just say a little bit of the overview of the whole task that we're working on. And there's still an opportunity to join this task, even though we're probably 2/3 of the way through. We have maybe a little over one more year if we extend it to go on the task. And it's basically looking at two technologies. So thermosyphons are the topic of today, but also PV generated hot water. So it's quite an interesting thing when you start thinking about it, because back when PV was hundreds of dollars per watt, maybe even thousands of dollars of watt when it first started, solar hot water was pretty much derived by solar thermal collectors, and thermosyphons are quite a good solution for that because they don't require a pump. But now the times have changed, and photovoltaics are now something closer, definitely below $1 a watt most places, and maybe even 50 cents a watt. And so it's starting to be pretty cost competitive to get your hot water from PV. So anyway, the task is kind of comparing and contrasting these two technologies and thinking about the issues that's barriers to entry and opportunities for further developments in those in both those technologies. So basically, any way that we can get solar energy into our hot water systems. Another interesting thing that unites these two technologies is they don't require a lot of moving parts, and they both can be pretty affordable. So there's some similarities as well. And the task has basically 4 parts to it. The first part, I think Bärbel mentioned, is drawing a little bit on sort of the work that's done by that Solar Heat Worldwide. So it's kind of just data collection of how many of these systems are installed around the world, what's the best practices for them, and like I just mentioned, barriers to adoption. And there's some interesting work going on, which I'm sure will be discussed in the Sol Train Plus program. And in fact, one of the interesting things in that's sort of associated with that is a test where they compare side-by-side thermosyphons to PV to heat systems at the Namibia University of Science and Technology. The second subtask in the task is about thermosyphon hot water systems. And then I think we'll probably discuss quite a bit of that today, but another part of it, which we won't discuss today, but you can get involved in if you're interested after today's session, is looking at energy savings and greenhouse gas reductions and things like that. And I think there's still quite a bit of work that can be done on these systems. I should also mention thermosyphon systems. For those who don't know, they look a little bit like these 2 pictures that are at the top of this slide, where you have the hot water tank above the collector, and they come in kind of mostly, for the most part, 2 different flavors. One is the flat plate collector, and one is the evacuated tube collector. And in both cases, as the water heats up, it expands, and that difference in density causes the hot water to rise up into the tank, and then the cold water from the bottom of the tank falls down into the collector, and you get a nice natural circulation there, and that's why you don't need a pump. And then, of course, from that tank of hot water, you can extract water and bring it down into your house for your washing dishes or cooking or taking a warm shower. In the third subtask C, we're thinking about these PV hot water systems. And some of the interesting ongoing work in there is we've done some surveys. We've been identifying some of the emerging technologies that are coming in around the world that are getting installed. And it's kind of a nascent market right now, but it's really set to grow a lot. There are ways to use your excess photovoltaic electrons. Instead of exporting them to the grid, you can put them into your hot water system. There's ways to directly put the electrons into the hot water. And then, of course, you can think about if you have just PV electricity on the grid, you can put that into your electric water heater. And an interesting thing about PV systems is it also can help the grid and balance the grid. So I'm sure some of you may know about this duck curve, which is the most famous animal in solar energy. And the duck curve happens whenever you get more and more PV on the grid. And as you do that during the middle of the day, you know, a lot of the demand is being met by the solar generation. And then in the evening, in the kind of the peak times, then you don't have the solar starts to drop off, right? Well, with a solar hot water system, you can actually kind of shift that around, because you can store some of your hot water during the middle of the day, and then you don't need to pull off the grid later. So it's kind of demand side management. So there's a value for that. And if you think about how much hot water is installed around the world, it's actually quite a lot. And so there's a big existing thermal battery out there in most people's households that have a hot water tank. And lastly, in the task, we're looking at different ways of boosting the training in these systems, which I guess this Solar Academy counts as one, and the standards that are out there across the world, and maybe what new standards might be needed in certifications for hot water systems. So for anyone that's interested to join the task, there's a little QR code there and also a link if we share these slides. We have a meeting coming up very soon in, I guess, 2 weeks in China. And then we'll probably have, we haven't decided the timing exactly or the location exactly, but probably sometime in April 2025 will be another task meeting later on. So I think that's it from me. So I'll stop sharing and can turn over to the next speaker, Erbil.
Good one, Robert. Thank you very much. A great insight, also appreciated from your insights from the Australian market, which is always a bit different than other markets as well, and seems far away from Europe at least. So we come to the next speaker, which is Li Bojian. We have joined 2 speakers today from China, which is really interesting. He is a researcher at the Solar Energy Application Center of the China Academy of Building Research since 2014, and he's professor since 2021. His research focuses on solar thermal applications and energy efficiency technologies in buildings. He holds a PhD in HVAC, and he also contributes to the national R&D program, which is titled Key Technologies and Demonstration on Zero Carbon Building in Solar Energy-Rich Regions. He will talk today about a special topic, which is called Initial Results of Failure Modes and Greenhouse Gas Reduction from Thermosyphon Systems. Li, I'm looking forward to your presentation.
Okay, thank you, Bevel, and I will share my screen. Okay.
Perfect.
Okay. Hello, everyone. I'm Li Bojia from China Academy of Building Research. I'm the subtask B leader of IEA SHC Task 69, as just now Robert introduced. And today I'm very glad to have this chance to share the initial results of subtask B, mainly about the failure modes and the greenhouse gas reduction on thermosyphon systems. Although today's PV water heater got great advance, the thermosyphon systems has also represent the majority of installed solar hot water systems. So in this subtask, we mainly focused on the thermosyphon systems to promote the thermosyphon system by improving their convenience and performance, and improving their durability and reliability through our failure mode survey and suggestions for different regions, and also investigate the energy saving and GHG reduction performance in different regions to tell people how the thermosyphon systems contribute to carbon peak and carbon neutral goals. The first part I want to share is about the durability and the reliability survey of our subtask. With Rudy and Julimo and SolarTree experts help, we have investigate and surveyed some failure modes, mainly from the Africa and South America region, and we divide there are 12 failure modes, and we divided them into 2 categories. First is design and installation, and the second is operation. For the design and installation, it's about the incorrect mounting and wrong position and missing insulation, and some other wrong position or designing not very good, not very well designing. And for the operation is about the leakage, antifreeze, and unsuitable control, corrosion, and especially in the South Africa region, we found the poor water quality has some impact on the solar thermosyphon systems. There are some examples. First is the incorrect mounting support for components, and this picture shows incorrect mounting, and the wrong way of installation of these systems would lead to a roof breaking that will damage the roof and lead to water leaks in the roof. Also in our report, we give the correct mounting method. And the second is the wrong positioning or installation of vacuum breaker. This picture shows an example. There is no thermosyphon loop in place to prevent backflow out of the tank in case there is no sufficient cold water supply. So if there is not enough water supply, the water in the tank will drain and make the tank empty when we use the electrical heating element that will cause problem. And the third example is missing solution. This is very simple. In this pipe, we don't have a solution that will cause extra heat loss and make the performance of systems become not very good. And so at the same time, they must use oversizing systems. The third example is corrosion. For the frequent deterioration phenomenon that has been detected in equipments that fail prematurely. Also, we could see this cracking make the durability problems for the thermosyphon systems. All these failure modes is not we cannot include all the failure modes in today's presentation. There are several other failure modes. We also have been detected, and we give some suggestions for different failure modes. But after all, we raised some suggestions for the total systems to cover different stages of thermosyphon systems, including design, production, installation, operation. Because we found many failure modes is caused by different reasons. But if we want to avoid these failures, we could go this way. First is to improving the standards and guidelines to give the system a better design and basic performance. In China, about 20 years ago, there are a lot of problems for the thermosyphon systems, but now we rarely heard some problems for the thermosyphon systems because the Chinese standards have been improved a lot, and they could maintain. They will give a basic performance requirement for the product. So the system design has been improved also a lot in recent. That make the product more suitable for the Chinese operation condition. The second is to improve the testing and certification that will improve the product quality and make some, for example, the corrosion phenomena could be avoided. And the third one is the training and qualification. Many failure modes occurred because of the incorrect mounting and operation. So if we could train and if we could train the workers to who install the system, or who will operate or maintain the systems. We could make the systems, we could avoid some failure modes. The fourth one is more more for the future, and the is a smart detecting with smart technology. We could install some smart sensors to monitor the system's operation and give the warning before the failure occurred. Maybe that will be happened in the future. So that's our four general suggestions to improve the reliability of and durability for these regions. So for the second part I want to share tonight is energy saving and GHG reduction testing results in China. First, we initiated this topic because we found the difference between IEA and China's figure. The solar heat worldwide give the GHG reduction of the global solar thermal is about 147 million tons. But in the Chinese report, the China's solar thermal GHG reduction is about 186 million, larger than the total world's solar thermal systems. So we are wondering why. So there are a lot difference between China and Europe and other countries may cause this difference in the greenhouse gas reduction of these systems. For example, the system type in China, this type of compact system is the most popular, and the hot water demand, the high-rise department building is more popular, and that may cause some difference of global for greenhouse gas reduction performance in China's solar hot water systems. So we want to know how much greenhouse gas does China's hot water systems reduce? So to answer this question, together with Solar East and Sunrin, our academy started a research on this topic to give a GHG reduction evaluation method and achieve the general figures about the GHG reduction in different cities in China as a reference for quick review. The approach the total approach to ensure the reliability of the method, we include these activities. First, we generate a general procedure to evaluate long-term GHG reduction performance of solar hot water systems. And then, according to ISO and Chinese standard, we give a method to get initial parameters for the different solar hot water systems. And with these initial parameters, we build up a model to calculate annual energy saving and carbon reduction of systems. We got this result, and to verify this result, we built a long-term testing field, and use the long-term operation data to verify the model results. And for the last, we simulate the GHG reduction of systems in different cities in China with our models. So this is a general procedure. First, we get some initial parameters such as heat gain, heat loss, and output water temperature curve. We use ISO 94592 as the main reference. But for the most popular system, the compact system in China, and the drain water temperature remains same when you as no cold water added when the water have been output from the tank. So we use the Chinese standard. 18708 to testing this type of systems and get the initial parameters. The second is calculate the annual energy output and saving with simple software. And this software could calculate the daily energy gain. And the method is similar to ISO 9459, just be modified to suitable for the compact system. And the third is to convert the annual energy output to carbon reduction. We use the electricity water heater as a reference system. So the carbon emission factor of electricity power in China is used to calculate this reduction. And this is a verification there was a newsletter in the IEA SHC website for to introduce this testing field. And this testing field was established in Jiangsu province with help of Solar East. And we tested a lot of type systems, including the Thermosyphon systems, heat pump systems, PVT systems, even PV hot water systems. But in this research or this subtask, we use this type and this type and this type to verify our model. And this type is a compact system. This type is a closed system, mainly used in the balcony of high-rise building. This is a result of verification. And for the first part is a compact system. And for the second is a pressured system. As I just told, this type of system usually used in the balcony of high-rise buildings. And this type is usually be more popular on the rooftop of buildings. So you could see the average daily heat gain of the compact system is larger than the pressure system because because the collector slope is much better for this type of systems, and the solar irradiation on the rooftop is much better than the balcony So, but for the deviation of testing result and calculated result, we could see the deviation is about 10%. So we think this model could be used for the long-term simulation. And to get the greenhouse gas reduction, because China is so large and the different city has different climate. So we choose 14 cities with different solar energy resources to calculate the annual GHG reduction for unit square meter collector of the solar hot water systems. And the figure is very different from 140 to 455. But to get an average for China, we use the population for different regions because the solar hot water system is so popular in China. Maybe almost every single family have this type of system. So the more people, more solar hot water system. So we calculate the average GHG reduction by weighting the population of each region and get the average figure is about 490 kilowatt hour per square meter collector, and the average GHG reduction is about 284 kilogram per square meter collector. So according to the Solar Heat Worldwide 2024, and the total installed collector in China is 545 million square meter. If all of them are solar hot water systems, we can get an annual GHG reduction is about 155 million tons. So this figure is more close with China's figure, and maybe larger than the solar heat worldwide figure. So for this is our initial results, and we are doing the further analysis, and maybe we could give more analyze results in the future. Okay, that's the main part. And for advertisement, we will have a meeting, as just Robert said, in this October, and the IEA SHC task meeting will be October 11th. And on the October 12th, we will have the sustainable solar building and industry meeting in China. And if you are interested, please contact this email, or you can contact us. Okay, that's my presentation. Thank you.
Thank you, Lee. A very interesting insight into failure modes and global warming potential reduction of solar water heaters. We have already some questions. Thanks for typing them in, but we will have a Q&A at the end. So feel free to go on typing in your questions. We have a next speaker also from China, a very well-known long-term in our industry. It's Chiao Quintai. He's Chief Engineer of Solar East Group, which is China's largest manufacturer of solar thermal products. They have different brands, including Sunrain, Mikoe, Sakon. He has been engaged in the technology development and product optimization of solar water heaters and systems for over 20 years. And he supported the development of more than 30 national and international standards and initiated more than 40 patents. So a well-known specialist in our sector. His speech today is about development status and future trends in solar water heating in China. So Chiao, the floor is yours, and we are a bit over time already, so keep the time, please. Thank you. So you go on presenter mode. It's already visible, only on presenter mode. No.
No? Hello, everyone.
No.
It's okay?
Yes,
Can you see
now.
that screen and hear my voice?
Yes, now you have to choose presenter mode. Which will.
Okay.
Yeah, that's it. Perfect. Super. Go ahead.
Hello, everyone. Thanks for Baba's introduction. My topic is current situation of solar water heater in China. Mainly, I focus on the thermosyphon systems. Actually, based on the Solar Heat Worldwide 2024, you can find in 2022, China new installation is account for 66% of global new installation of solar collectors. And the total installed capacity in Chinese market until 2022, it account for 73% of global total installed capacity. So no any double. China is the world's largest market for solar thermal utilization. But when you notice this figure, you can find there are one very important the year is 2013. This is for the global market, but mainly it's because the Chinese market. This figure shows the Chinese market and the European market. The blue line is the European market, is more stable. But for the Chinese market, the yellow line, you can find before 2013, Chinese solar thermal market grows very, very fast. But after 2013, the market is decrease is also very fast. So we usually said in China, we said 2013 is the water sales year for Chinese solar thermal market. And in China, the main product is the very typical solar thermosyphon water heater with a vacuum tube. And the principle is very simple. When the vacuum tube absorbs the solar energy, will be heat the water in the tube, and the high temperature water will go up, low temperature water will go down. So we will heat the water in the tank step by step. And we're going to talk about the reason for the rapid development of the market before 2013. But there are so many discussion and even argument. But for my personal opinion, I think maybe there are some reason below. The first is before 2000, Chinese urbanization rate was very low, only 35% in 2000. That means around 2/3 of people living the countryside. And during that time, most of people bath in public bathroom, but people want to bath in their own house, So energy supply also inadequate. There is no natural gas supply in the countryside, and the electricity grid is also very weak. Even in large and medium-sized city, the gas and electricity supply are insufficient. So at that stage, solar water heater were almost only products to solve the problem of bathing in the home, especially in the countryside. And in rural area, the solar water heater are the most important products after TV sets. And in the city, the first things after people buy an apartment is to occupy a spot on the roof that can be installed with solar water heater. And sometimes the location of solar heater needs to be purchased additional. It's difficult to find the place to install the solar water heater. And also, Chinese government also has some incentive program to encourage the people use the solar water heater. So before 2013, the market increased very, very fast in Chinese market. The reason for the market declines after 2013, and also because the urbanization rate in 2023, the urbanization rate is 66%. That means most of the inhabitants live in city. And all the energy supplies become better and better and very plentiful, especially in the city. And even in remote rural area, electricity supply have improved very quickly. I think China has a very strong power grid for the electricity. And also in the city, there are more and more high-rise buildings replace the original ground floor building. And for the high building, there will be no enough space on the roof to install the solar water heater. And for the high building, too long hot water pipe affect the user experience. And compare with other products such as gas water heater or electric water heater, the weakness of solar water heater also appears, such as the pressure and temperature is not so stable, and the efficiency sometimes is different in different season. In winter and summer is a big difference, and also the different installation, different type of solar water heater is the efficiency or the use experience is different. And also the initial investment of solar water heater is also higher than the gas or electric boiler. Another very important reason is the energy price for Chinese householder are very stable, such as for the electric price, now the price nearly the same as 30 years ago. That means 30 years ago, when people purchase a solar water heater, you can tell them, okay, 1 year the solar water heater can save 400 to 500 RMB per year. And okay, people think, okay, this is a good product because can save very good money. Nearly with 400 to 500 RMB means nearly 1 month's salary. But now, if you told the people install the solar water heater can save 500 RMB per year, we take no care about this because this is only this. And also, the government incentive have also shifted to photovoltaic, wind energy, and other industries that can bring more industrial output. So this caused the decrease of the solar thermal market. But another is things is in China, the main product of solar thermal is different from Europe. In China, the main products is vacuum tube solar collector, but in Europe is flat plate solar collector. Actually, China has all the products and technology related to the thermal utilization. Why the vacuum tube is more popular than the flat plate collector? That is because the market development strategy is different. The initial Chinese water heater market customers are concerned about economic rather than the comfortable. And the vacuum tube Thermosyphon solar water heater have so many advantages during that time. That is a reasonable price, simple installation, easy after sale, and wide application area. Yeah, even in North China, very cold weather, the vacuum tube solar water heater can work well. So it's very suitable for the Chinese market. However, the production process of vacuum tube is complex. Especially is accounting for the production of borosilicate glass tube must be continuously produced, which is only suitable for the large enough area of the single market. If the single market is not huge enough, it's difficult to produce the vacuum tube. Such as the cone, the lifetime of the cone is around 3 to 3.5 years. That means during the 3 years, the product line cannot stop even 1 day. So this is the market should be huge enough. And the vacuum tube is suitable for non-pressurized Thermosyphon solar water heater. If the vacuum tube is used for pressurized solar water heating system, the price will rise significantly, which affects the promotion of vacuum tube collector in the market of pressurized products. This is why in China, the main product is vacuum tube collector. This is a process for the vacuum tube, the glass tube, and vacuum tube. Another point, in 2022, the flat plate solar collector account for around 27 of new installation in China. Compared to 2008, the flat plate collector account for only 8% in China total installation of solar collector. And the new installation collector area in 2008, the flat plate collector only account for 5% in China. That means that even the market decreased, but the flat plate collector increased faster than the vacuum tube collector. That is because in the city, more and more high-rise the building. And for this building, it's very difficult to install the vacuum tube solar collector on the top of the building. Just as I mentioned, there's no enough space for the solar water heater, and also the very long hot water pipe is also is not suitable. And so in China, we developed a balcony system. That means we install the collector out of the balcony, but the tank in the balcony. So this solves the installation on the high-rise building. But because the collector installed out of the balcony, so the safety is the most important concern. So people prefer to use the flat plate collector because the cover glass of flat plate collector is tempered, is more safety, but the vacuum tube is not tempered. Another reason is for the growth of flat plate collector is due to the reason of economic development. Customers are more concerned about the stability of the hot water system and the comfort of use. So more and more customers are more willing to choose the pressurized hot water system, especially for the industrial process heating and the space heating, the large scale space heating system. So the flat plate solar collector has more development opportunity. In conclusion, Chinese thermosyphon solar water heater face strong competitions from electricity water heater, gas water heater, heat pump water heater, also the PV. And the market continues to decline, but so many companies have turned their eyes to solar district heating, industry and agriculture applications, and even heat pump. But thermosyphon solar water heaters have huge potential in South America and Africa. For example, China exports nearly 1 million vacuum tube solar water heaters to Mexico every year. Okay, thank you for your attention.
Thank you, Jiawu. A very interesting report about Chinese market development. I really like the huge high-rise buildings with the big thermosyphon systems to the very top floor, which is really fascinating. This only exists in China for sure. So we have a last speaker who will cover a completely different region again. Thanks for that, Rudi Moschek. He is senior engineer at the Austrian Research Institute INTEC. He has over a decade of experience working with solar collector systems for solar hot water in Southern African Development Community, SADC in short, region, which is the Southern African countries. He was involved in a lot of field visits and installation and trainings in the SADC region, and he will give us a very detailed insight into the current situation and development in this part of Africa. So, Rudi, I'm looking forward to your presentation.
Yeah, thank you, Bärbel, for the short introduction. Hello, everyone. I hope you can see my screen now.
Yes, not in presenter mode yet. Perfect.
Okay. Thank you again. Hello, everyone. My name is Ude Moschik, working with AE Intec. And as Bärbel has mentioned, we are working a long time in several continents, but our main focus is Africa. There we are working in our SolTrain project. SolTrain is a regional project in 6 partner countries, and we have several partners in these countries assisting us and doing our activities and work. And the overall goal of SolTrain is to assist in the transition from the mainly fossil fuel-based energy supply to sustainable and renewable energy supply systems in future. Basically, we started with SolTrain in the year 2009. We are at the moment in, let's say, the 5th phase, the SolTrain Plus phase, going on from January 2023 to December 26. So we have still some time to go. And what is our approach? What is our concept in this project? We have on the one side a lot of training activities. We do research and development. We have a lot of awareness raising topics. We try to combine all stakeholders and provide information about regulations. SolTrain provides also some funding incentives, and out of this, we establish a lot of demonstration projects. In this actual phase, SolTrain Plus, we have, in addition, now some new topics. This is on the one side, combination of heat pump and energy efficiency in combination with solar thermal. And our strong focus is on training activities for trainers and instructors and for industry. For this presentation, I give you a short summary of my content for today. Just a brief situation about installations. We have heard already a lot in the previous presentations. I will show you some results, roadmaps, and the potential we have in Africa. Of course, the challenges and requirements, which are very, very important to be successful in this technology, and a short overview about best practice and cost situation, and the final conclusion, which is always or also summarizing what we have heard already in the previous presentations. In the current SolTrain phase, or in the last SolTrain phases, basically, we have funded more than 700 systems within the project. And these 700 systems resulted in more than 7,000 square meters of collector area. Sorry. In this presentation, I have included some pictures of standard Thermosyphon units, you see, for single family houses, but also for staff units, for residential houses, and for student hostels. In South Africa, as mentioned also before, there's a big trend also going to PV to heat. So You see here the number of installations, which was increasing rapidly the last 3-4 years. So having installed more or nearly 10,000 systems in 2023. And of course, this market with lower PV costs will for sure become more interesting in the future. On the other side, when we have this available data analysis by Solar Heat Worldwide report, where we cover more than 70 countries in the world and are able to compare the yearly installation and the all necessary market data for this technology. We see, especially in Africa, in the sub-Saharan region, we have about 13 countries, but still Africa also here is somehow a black continent. A lot of countries are not really delivering data for this yearly report. So also here we have to look forward how we can improve here to get also information about installation in the other countries. We have seen this graph already before. So how much is the percentage of installed capacity divided by Thermosyphon technology or pumped solar heating systems? So still Thermosyphon systems are the larger market worldwide. If we look on installed capacity and going in here in detail to Africa, you see that the main market is Thermosyphon systems, so more than 66%. Having a very short picture in the past, so having the year 2022, we see that the total distribution of Thermosyphon systems worldwide is going down. So we have also heard the reason, mainly China, because they switch from Thermosyphon units to pumped systems, and mainly going also for very large pumped systems. We have seen some pictures before. In Africa, it's the opposite. So there is still the Thermosyphon market very relevant and is dominating and is increasing comparing to pumped systems. One main aspect in our SolTrain project was also to give a guideline how do different countries reach certain goals, and therefore we have established in many countries our solar thermal technology roadmap. They are available. Unfortunately, I have not put here the link, but they are available under our SolTrain website. And in this solar thermal roadmaps, every country has set their own targets, how much square meter, how much capacity they want to install by 2030. As an example, this is somehow the vision of Zimbabwe. We see on the one side, they have a target of 0.1 square meter per inhabitant by 2030. If they will reach this number, this will result in an installation area of 2 million square meter. How is the status at the moment? According to this roadmap, and basically Zimbabwe is good on track, they should have installed in 2022 about 40 1,000 square meters according to the roadmap. If we go now in with the data of the market reports, the installation, so the measured or the documented installation in Zimbabwe in the year 2022 was 33,000 square meters. So, and having the roadmap in place, having somehow the vision and the goal, you can always compare where are you at the moment and how far have you to increase your action to reach the final installation area. Also, this graph is a very good presentation of the current status. If we look here on these yellow spotted countries, these are all countries in the SADC region. There we have at the moment the highest specific installation capacity in South Africa, 15 kilowatt thermal capacity installed per 1,000 inhabitants. And this is representing 0.02 square meter per inhabitant. The lowest value we find in Mozambique, where we have for sure a lot of issues to and struggle a lot to implement solar thermal technology. On the other side, leading countries, on average, the 3 leading countries have installed already 490 kilowatt thermal capacity per 1,000 inhabitants. And this is equal to 0.7 square meter per inhabitant. So if we come back to our vision plans, 0.5, 0.1, 0.3 square meter per inhabitant, we see there is still a lot to do in Africa. So if we go for South Africa, who has the vision with 0.5 square meter per inhabitant, there is a factor of 20, which they have to increase their number of installations. What are the challenges? And we have heard already today some of these challenges which were also occurred in China 20 years, 10 years ago. So on the one side, especially in Africa, there is no certified body. There's no clear standards available. Quality management, quality of installation is not the best one. Some countries adapt existing standards which are partly 20 years old or even older. And also the knowledge of installers and producers regarding the use of standards is limited. And therefore we have a big issue in quality of installations and also in the choice of choosing quality systems. On the other side, which is also very obvious, there is a lack of maintenance. Sometimes I have the feeling this word doesn't exist in Africa. But if we look in the, let's say, car sector, mobility sector, there they offer and do a lot of maintenance. And also this activity is required to have a long-lasting solar thermal system. Another issue in Africa, especially in Africa, is the initial investment. We are all aware solar thermal systems needs a higher investment at the beginning, and afterwards the energy is nearly for free. So the sun is not sending us a bill. On the other side, local energy, especially electricity, is cheap and mainly subsidized by the governments. So also this is a barrier for introducing other technologies. There are also nearly no funding schemes available to overcome this issue. We are working now in Soltrain and hopefully in Namibia and Zimbabwe. We are very close to have bankable proposals for investors to be able to have sufficient funds for installations. We have seen already some issues which we have during the installations. Lee has mentioned some. Yeah, some are very obvious. You see this installation is upside down, and the installer was really insisting that this system was working, but the heater was just or the water was just heated by electricity in this case. We have seen already this picture, missing insulation, insufficient fixation of the systems. And of course, if you don't follow some standards, you get also this night art installation of solar thermal systems. Therefore, and this is a main aspect of Soltrain project.
Can you speed up a bit, Rudi?
Yeah,
because of our Q&A.
Okay.
Yes.
Quality installation, maintenance is very, very essential, very important. And we have some best practice examples, systems which are working already nearly 20 years with nice maintenance. When the picture on the right side, this system is nearly 20 years old. It's not looking like this, but it's 20 years operating. We have quite high solar resource in Africa, nearly all over Africa, and done a lot of evaluation and monitoring. We can somehow work with a solar yield of more than 750 kilowatt hours per square meter and year, and having much better climatic conditions comparing to Europe and China, we can easily reach a solar fraction of 95, sometimes 100%. Also, the cost perspective is always an issue. So we find here, but this is an evaluation of more than 300 systems, which were done the last 3-4 years. And you see in the first column, we have just direct thermosyphon systems. So they are the cheapest with an average cost per square meter around 400 euro per square meter. The indirect thermosyphon system with flat plate collectors are a little bit more expensive. So we have maximum price with 800 and the average price of 550. And the indirect systems, which are dominating the market at the moment, they are also in the range of 420, 430 euro per square meter. So coming to my conclusion, and this was also mentioned before, on the one side, we need clear definition of the quality of installations and material. A lot of training activities in all sectors are required. And here the people really need experience by doing practical installations. And finally, we need the quality control to really achieve these goals of sustainable and long-lasting systems. So far, a last impression from nice African continent. So it's really a fascinating continent, and hopefully there is a big potential, a big market, and a lot of possibilities. Thanks very much.
Rudi, thank you. This was a nice last photo. And this inspires me at the same time to pick the question here on how we should give instructions to architects and how to fit solar water heaters nicely on the roof. Rudy, do you have experiences with that to even place? I think there are tanks which are placed below the roof now and the collector above so that it's not so obvious. Do you have tips for architects?
Yeah, I mean, this is a good question and a difficult question because architects are looking on the view. Yeah, so they are not looking on the technical perspective of the whole building design. In this case, I guess thermosyphon units will not be the right technology. Yeah, and here we see big, let's say, advantages with PV. Yeah. I guess this is not the market for thermosyphon systems. So here we have to think about other technologies. Yeah.
Okay. So the Q&A is open. You can all get your cameras on, please, the other speakers. I have another question for you, Rudy. I think that concerns the reason for the growing PVT to heat market in South Africa. Is it price, reliability, suppliers? What are the reasons?
The main reason is that there is an obligation in the building standards that every building has to overcome more than 50 or 60% of their energy consumption with renewable energy. And of course, therefore, heat pump is one option, solar thermal is one option, PV to heat. And when we have also mentioned today, because the cost of the PV model are really coming down every month. Yeah. On the other side, the advantage is, it's not the best solution, but the advantage is they are using the existing hot water tanks, the electrical geyser tanks, and therefore they can save a lot of investment, but still having low efficient components in the system. And nobody is testing and checking this. Yeah. So if you invest in a good tank, PV to heat system is still more expensive comparing to a solar thermosyphon system. But initial investment can be cheap. Installation is simple, easy, and you have also this point that you don't have to put a storage tank on the roof.
Yeah. Robert, for you, you want to add something there?
I just want to say one thing on that last issue. There's some reliability and durability advantages as well. You don't worry about freezing for a PV system. And of course, there's no, if you lose water for whatever reason, which can happen in some places, then you don't have corrosion and things happening in your solar collector.
Okay.
Yeah, Robert, I mean, you are right, but again, the problem is high standard of material and installation. If you follow here the standards, you don't have the problem with corrosion and leaks, and usually the system can stand stagnation, everything. But it must be installed in high quality.
There's a general question from the beginning, Robert, to you. What are adapted strategies to optimize thermosyphon systems? What have you learned in the task here?
Well, I think some of the opportunities, I mean, I should say something before I go on that. One thing about thermosyphons is they can still get above 50% efficiency. So if rooftop space is a big issue, and you want to get a high solar fraction for your building, thermosyphons are still a good solution. But one of the opportunities is we have a lot of new electronics that can control things automatically on the rooftop, and monitor state of charge in the tank and do some of this kind of maintenance checking things. And check for the corrosion happens when you get a certain percentage of impurities in the water and things like that. So you can monitor these things now with smart systems. And even though thermosyphon's kind of uncontrolled, you could theoretically have some smarts embedded in there. I think that's one way that you could get a lot better performance. And also the electronics are getting a lot cheaper and better these days as well. So I think probably some of the Chinese manufacturers may be able to comment more on what's the emerging things for that. But yeah.
Yeah, actually, Jiao, we also have the question to you how your strategies are to promote you know, thermosyphon systems in China. You can also maybe get your camera on.
Yeah. Yes, sorry, I cannot open the camera, but I don't
Okay,
know
no
the
problem then. Okay, at
Okay,
least you
for the
are there.
strategy of the thermosyphon, the solar water heater in our company is I think is very clear. The overseas market. I think there is just as mentioned, there are very huge potential market in South America, Africa, Southeastern China. So the overseas market is our strategy.
For thermosyphon systems, not the Chinese market?
Because the thermosyphon system. The thermosyphon system in China, I think, will be difficult.
It's difficult. Okay. There's one question about these balcony systems. You know, the question was whether the only reason to bring up flat plate collectors in the balconies in high-rise buildings is because of the tempered glass, or whether there are other reasons why you put
the main reason
plate.
Is because the tempered glass is more safety. It's not so easily broken. But another thing, another reason nearly the same. Also, that we can use the vacuum tube collector out of the balcony, but that the balcony system usually is on the high building. That means very difficult to do the maintenance. Even when the tube broken or sometimes some other problem caused by such as the stagnation, you need to replace one of the tube. It's not so easy out of the balcony.
Okay.
Yeah.
And that's
the safety
interesting.
and the maintenance.
Okay, thank you. Lee, can you say something about PV to heat systems and their their prominence in the Chinese market and their competition with thermosyphon systems?
Sorry, from my view, I think PV to heat systems. Now we have some product in we have many products in China, in Chinese market, but the application is not is few. So I think this is in a start stage, and maybe in few years the PV to heat systems will become more and more popular in China.
Okay. How about in China, the roof space? If it needs to be divided, if you have a high-rise building and a limited roof space between PV and solar thermal, is there a competition on the two technologies on the roof, or what technology is usually used first then?
Sometimes it not depends on the technology. Maybe it depends on some other reasons. Because in China we promote solar hot water systems for so many years, so people is familiar with this type of system. So if you ask the architecture to design solar systems, maybe he will choose solar hot water systems first, because he will think, okay, it's very it will have no problem, it's very easy. But if you ask him to design solar PV heat systems, maybe he will think, oh, that's new. Sometimes it's not very reliable, maybe, and so they will be, maybe they will not very positive for this type of system. So this is maybe it's not depends on the technology. It sometimes it depends on this kind of things.
Knowledge and awareness.
So, yes, so with the systems become more and more, and if you could see the PV to heat systems anywhere, So people will think, okay, okay, this type of system is also okay and also easy. So they will get more and more popular.
There is another question to you, Lee, regarding your failures. Somebody says that I felt that the failure modes part focused mostly on failures related to mounting areas and poor material choice. Can you have more information on design-related failures, especially for evacuated tube collectors?
Yes, I think in the very first we thought we will gather some design-related failures, but not so much. I think the main point about the design failures or design problems is sizing the collector area and sizing the tank volume, and that it depends a lot on about the condition, weather, climate condition, solar condition, and the operation condition for this system. I think maybe for the I think it's not very it's not a problem in China, and I think maybe Mr. Jiao Qingtai, their company have a lot of experience about how to design a thermosyphon system for different place, for different region.
Okay. Thank you. Jiao, there's a question on can you please elaborate why pressurized flat plate collectors is more reliable than vacuum-based thermosyphon systems? Would you generalize that, or is it only for this facade?
Yeah, for I mentioned in this presentation, I mentioned the thermosyphon system usually means the water in the tube, the solar collector. That is water in the tube. Sometimes, just as mentioned, the glass tube sometimes is broken by outer force, or sometimes broken by the stagnation, temperature, such as, so that is not so stable as the flat plate collector.
Okay, thanks, perfect. Rudy, there are two more questions from your side. First, we have a participant asking whether it's necessary to, if you want to do an installation in the SolTrain project, that the solar water heater is certified by EN 12976, probably solar key mark.
So basically, we have some regulations, some framework regulations in our project for funding demonstration systems. And we ask for certification like Solar Key Mark or SRBS test. So this is a recommendation, because we want to make sure to use quality products. So this is the reason behind, but we are also assisting companies who have some local production. So SolTrain is also willing here to assist to figure out if it's possible to get somehow such a test certificate. On the other side, we know this from many different projects and regions, I guess Jiao maybe can also inform us here about the development in China. China, as mentioned before, they see the main market, emerging market in Africa, in South America, in these hot climate areas, and you get really quite good material components out of China. So high quality components material. But unfortunately, you get also lower quality. And having this possibility or requesting some test certificates, that's one way how we can divide a little bit good quality from bad quality.
Good. I understand. Yes. We are almost out of time, Rudy. A short question towards piping and insulation. If it's high ambient temperatures, a usual practice is to leave the pipes without insulation and also use PEX pipes, so polymer pipes for hot water conduction. What is your opinion on that? And why are they using copper instead of PEX in South Africa?
Yeah, and on the one side, in the collector loop itself, we never recommend polymeric materials. So of course, in cold water and hot water distribution line, you can go for polymeric materials, but not in the collector loop itself. If you go with flat plate collectors, copper is quite usual material in South Africa. They produce copper in South Africa and also Zimbabwe and Botswana. They know that this material can stand UV, high temperatures, high pressure. So these are advantages, especially for long-lasting designs. And of course, you get also good quality polymeric material, but the limit is always pressure and temperature. And in Africa, we have the UV radiation. The second question was insulation. Yes, we recommend also in hot climates insulation. And we know, like Namibia or Zimbabwe, they are hot climates, but they have freezing condition in wintertime and during night. And also this we have to consider. And finally, we want a high efficient system. We don't want to heat the environment. So we want to keep the heat in the tank. Therefore, we also recommend good insulation products.
Good. Who can answer very fast the question about backflow prevention? Jiao, in Thermosyphon systems, backflow prevention, how is this realized? A very short answer.
Yeah, there's two. One is insulation and one is the correct height distance configuration of tanks, pipes, and collectors.
Okay. Hopefully this helps our participant. Good. Thank you so much. It was a great panel. I hand over to Arabella. Thanks for the interesting presentations and the engaged Q&A.
Yes, thank you, Bärbel, and thank you to all the panelists for your presentations. Thank you for the audience for attending. I'm just going to quickly show a few more last informations, which will be interesting to you. One is that the webinar has been recorded, and we will share the recording as well as the presentations online in a few days, and that will be both on the ISIS homepage and of course the IEA SHC Solar Academy homepage. For any ISIS members who are on this webinar, you remember you already have access to many of the webinar recordings in the ISIS webinars archive, so that's always a good place to check as well. And then finally, before we close, I want to share some more information on a next event that's coming up for ISIS, and that's going to be of interest to you. And that is the ISIS Solar World Congress 2025. You've seen it at the very beginning of my presentation. We have announced the save the date for this conference. It's going to be from the 4th through the 7th of November 2025 in Fortaleza in Brazil. Interesting fact, this is going to be right before the next COP. The next COP, not the one this year, but the one next year, will take place in Brazil, quite close by to Fortaleza. So if you're interested in attending an ISIS Solar World Congress, mark your calendars now, and we will share more information on the Congress and obviously also the call for papers in the coming weeks and months. That's my final information for today. Thank you everybody for joining, and we will now finish the webinar. Bye.
Bye-bye.
Okay, thank you. Bye-bye.